Hello students, today we will learn about Earth's energy balance model and Earth's average mean temperature. Do you know energy balance model calculates Earth's average mean temperature as minus 19 degrees Celsius, but in actual Earth's average mean temperature is plus 15 degrees Celsius. So why there is huge difference of 34 degrees Celsius? So today we will learn about that. Basically, the energy balance model is nothing but a balance between the incoming radiation and the outgoing radiation between the sun and the earth energy balance system. So when the sun rays falls on earth, earth receives the sun rays like a circular disk. It does not receive or intercept solar radiation on whole of its surface at one time. It receives like a circular disk, and that disk has a radius that is r. So the area of the disk which is intercepting the solar radiation is pi r square, and S here is a solar constant, which is 1370 watt per meter squares, which means that 1370 watts of solar energy, or you can say the intensity, Earth is receiving at top of its atmosphere per meter square. And now the albedo comes to the picture. What is albedo? Albedo is the total solar radiation reflected back by the Earth, by the atmosphere, by the clouds, and by the ice. So albedo is 0.31. So 31% of the radiation, solar radiation, is reflected back by the Earth system, by clouds, by atmosphere, and by ice. So the total absorbed energy is S pi r square 1 minus alpha, because total reflected back energy is S pi r square into alpha. So till now we have discussed the incoming solar radiation. Now we will talk of the outgoing infrared radiation, which is radiated back by the earth. Infrared, why it is called infrared, this we will learn in the later videos of this series. So firstly, let's discuss the outgoing radiated back energy from the earth. So here comes into the picture the very important radiation law. There are four important radiation law of physics. These are Stefan Boltzmann law, Planck's law, Wien's displacement law, and Kirchhoff's law. So firstly we will discuss here Stefan's Boltzmann law, which simply says that energy radiated per unit area by any black body is directly proportional to its temperature. That is, it depends upon its temperature. E is equal to sigma T raised to power 4. So now Earth was receiving energy in the form of a circular disk, but now it is radiating the energy back from its entire area. So the total energy radiated back by Earth is 4 pi r square sigma temperature T ki power 4. Why 4 pi r square? Because E in the Stephens-Boltzmann law was energy radiated per unit area, so we need to multiply by area, that is 4 pi r square, if we are considering Earth as a sphere of radius r. And here sigma is Stephens-Boltzmann constant, which is 5.67 into 10 to the power minus 8 watt per meter square Kelvin 4. So now as per energy balance model, we got two equations. One is total energy absorbed by the earth, and second is total energy radiated back by the earth. So in the total energy absorbed by the earth, we have S pi r square 1 minus alpha is equal to now 4 pi r square sigma T raised to power 4. So on simplifying, we will get S into 1 minus alpha upon 4 is equal to sigma T4. So on simplification, putting the values of S 1370 watt per meter square and sigma value 5.67 into 10 to the power minus 8 watt per meter square Kelvin 4, and putting the value of alpha, that is albedo 0.31, we will get temperature value as 255 Kelvin, that is minus 19 degree Celsius. So now we got the temperature value, Earth's average temperature is minus 19 degrees Celsius, but in reality we know that Earth's average temperature is around plus 15 degrees Celsius. So why it is plus 15 and why we are getting minus 19? Because atmosphere plays a role. Gases present in the atmosphere plays a crucial role. They warm the atmosphere. The gases trap the outgoing infrared radiation and re-emit them to the atmosphere, and Earth's become warmer as compared to the value we are getting from Earth's energy balance model. So we will discuss this point in detail in the next videos of this series of the greenhouse effect. Till then, goodbye.